Hello guys, so in this video I want to talk about the container adapter, which is a stack. All right, and this goes with the last in first out, right? LIFO. Pretty much if you can think of about a stack of books, the one at the bottom would be the first you place, and then you would stack some more books here. But to get them, to retrieve them, the last one you put in would be the first one you can get out. All right. So here I have an array 10, 20, 30, 40, 4 elements, and I'll put them into a stack. So the syntax for stack would be stack type, right, and name of the stack. Now type could be int, could be string, etc. All right. So in this case, I have the name is s, it's an int, and I have the keyword stack. Good. So what else you need to know here? You just need to know a few functions that are associated with stack, and you can see we have push. Push means here we are placing elements on the stack, right? S.push would place an element on the stack. S.pop would remove the topmost element. So if there's one, it would remove that one. And empty would just check if it's true, it will return 1. If it's false, it will return 0. So here in this code, what I'm doing basically, I'm placing some elements on a stack, 10, 20, 30, and 40, and then I'm removing them. So the first element would be the last to be removed, and the last element would be the first to be removed. So key terms for stack, we got push, we got top, we got empty, and we are using a range base for loop to iterate through the elements and place them in a stack. All right, so let's run this code now. So here we go. You can pause the video and take a look at the code, but pretty much we have the syntax for the stack, we have the array, we're just saying pushing the elements to the stack, then we are iterating through this array ARR. So A of of 0 would be 10, so that means we are pushing s.10. Then we are outputting that we push 10, and then we are putting 20, 30, 40. So we'll have those elements, and then we are popping them out. We are saying if the stack is equal, if empty is false, that means the stack has elements on it, while this is true. Print the topmost element and then pop it out and then iterate through, right? So while right, so we have a loop here, right? When we pop this element, it's gonna go up again, because first time we iterate through this loop, we'll have the condition is true, so we will pop then we'll go again until this condition goes to false. So s dot empty equal false in this case means that if the stack is not empty, right? S dot empty equal true would be if it's empty. S dot empty equal false would be if it still has elements in it, right? Okay, so let's run this now and see what happens here. So kind of run this. So what I'm doing here, G++, std, and name of the program is stack.push, and my output will be stack.push, and it's stack push.cpp. So I just run this program, so I might as well toggle through this. So let's see what's happening here. Stack push. Okay, so you can see here, right? The elements 10, 20, 30, 40 were placed on the stack, and then we pop them out. So that is what I was saying here, right? 10, 20, 30, 40. So they're on the stack. So the first element went to the bottom and the last element went to the top. And when we are removing the elements, we're printing out the topmost element. Look at line 19 here, would be 40 followed by 30, 20, and 10. And this is all this code is showing. How you have first in, last out. I'll stop here for now, guys.